Looking at section 4.5, part 2, this time we're going to look at the graph of y is equal to cosine of x. So similarly to what we looked at yesterday, we checked out what happens with our sine function as our point travels around the unit circle. What happens with our cosine function, if we were to look at as our point goes around the circle, this time when we are at 0, our cosine function is at a positive 1. And as we travel around the unit circle, once we get to the pi over 2, that's going to have a cosine value of 0. As we continue going towards pi, we're going to get to our minimum value, or our least value that we're going to have in this case is a negative 1. And as we continue on, going around our unit circle at 3 pi over 2, it's back at 0. And as we continue all the way back a full circle, back to that 2 pi, we're now at a positive 1 again. So our cosine function, a little different than our sine function, is going to start at positive 1. It's going to travel down to negative 1 and then back up to positive 1 as that point travels around the unit circle. A little different than our sine function that started at 0, went to 1, down to negative 1, and then back to 0. So our sine and our cosine functions look very similar, except the starting point. So if we look at some of those key points, just like what we did yesterday with our sine function, when we are at an x value of 0, that's where we have a positive 1. When we travel around as we get to that pi over 2, that is where we end up with a value of 0. When we get to pi, we are at negative 1. When we get to that 3 pi over 2, we're back at 0. And we get to 2 pi, we're back at that positive 1. So what happens with our cosine function, we start at 1, go down to the negative 1, and then end at that positive 1, crossing over that x-axis 2 times. So we still have our 5 key points. We have 2 x-intercepts, and then we have 3 points that are falling at that maximum and minimum values. So some properties of our graph of y equals cosine of x. The domain, there's still no limitation on what we can put in. We're negative infinity to positive infinity. The range, as long as we're dealing with a radius of 1, goes from negative 1 to positive 1. The period on cosine is 2 pi. And the function is an even function. So the cosine of negative x is equal to the cosine of x. And if you remember, an even function meant that we had that y-axis symmetry. So whatever's happening on one side of the y-axis is going to be mirrored to the other side of the y-axis. So some sinusoidal graphs, right? We have our sine function at the top and our cosine function at the bottom. It says the graphs of sine functions and cosine functions are called sinusoidal graphs. It says the graph of y equals cosine of x is the graph of y equals sine x with a phase shift of pi over 2. So if all they did was take the graph of a sine function and shift it over to pi over 2, you'd end up with that cosine function. So they tell us that cosine of x is equal to sine of x plus pi over 2 with that phase shift in there. So graphing some variations of our y is equal to cosine of x. It says the graph of y equals a cosine of bx. It says the graph of y equals a cosine bx, where b is greater than 0, has an amplitude of the absolute value of a, just like our sine function. The number in the front tells us how high above the x-axis it goes and how far below the x-axis that goes. It has a period of 2 pi divided by b, just like we did with our sine function. So looking at an example, it says to graph a function of the form y equals a cosine of bx. So we're going to look at y equals negative 4 cosine of pi x, and it says to then graph the function for negative 2 is less than or equal to x, which is less than or equal to 2. So step 1, identify the amplitude and the period. So the number in front of our cosine function, we have a negative 4. So the absolute value of a negative 4 is going to give us 4. That means our graph is going to hit at the maximum positive 4 and at the minimum negative 4. The period, we take 2 pi divided by b. Well, our b value in this case is a pi. So if we take 2 pi divided by pi, that means we have a period of 2. Step number 2, just like we did yesterday, our 5 steps, we are going to find the values of x for those 5 key points. Now the period, we ended up with an answer of 2. We have a period of 2. Now we have to take our period, which is 2, and divide by 4. That's what breaks those into those 5 pieces. 2 divided by 4 means we have a 1/2. Now our x1 value, we did not have any sort of phase shift that occurred within this cosine function, so our x1 value is going to be a 0, and we're just going to add increments of 1/2. So if I take 0 and add a 1/2, our x2 value is going to be a 1/2. If I take a 1/2 and add a 1/2, we're going to end up with 1. If I take 1 and I add a 1/2, I'd have 1.5, or if you want to call it a 3/2, either way. And then our x5 value is going to be taking that 1.5 or that 3/2, adding 1/2, which gives us 4/2, which is equal to 2. So now that we have those 5 key points, we take it to our table. All right, we fill in our 5 key points, and then we evaluate our function for those. So we have -4 times cosine of pi times 0. Well, if I have a pi times 0, that means I have a cosine of 0. And cosine of 0 means that we are at 1. That means we're going to have a -4 times 1, which gives us a -4. So we're going to have 0, comma, -4. I have 1/2 of pi, which means that we have cosine of pi over 2. Well, the cosine of pi over 2 gives us 0. So -4 multiplied by 0 gives us 0. So when we're at 1/2, we are at 0. -4 cosine of pi times 1, so that means we just have pi. Cosine of pi is going to give us a -1. So -4 multiplied by a -1 is going to give us a +4. So when we're at 1, we're at I wrote a negative. When we're at +1, we're at a +4. If we were to evaluate that at our pi times 3/2, so 3 pi over 2, then we're going to have a cosine value of 0. So -4 multiplied by 0 would give us 0. So when we're at 3/2, we're at 0. And then when we have 2 pi, what happens when we're all the way back full circle? We're going to have -4. That's going to multiply by 1, which gives us a -4. So when we're at 2, comma, -4. And now that we have our 5 key points, we take it to our graph. So when we were at 0, we were at -4. We had the 1/2. We had at 1, we were at 4. At 1.5, we are at 0. At 2, we are at -4. And then that would have completed one full cycle, or one full period, right? In order to go up and then back down. But they had wanted from -2 to +2. That means we need to extend that out so it goes from -2 to +2. Let's try another. Or what happens when we add on our y is equal to a cosine of bx minus c? What happens when we get into that phase shift? Again, if you remember, we said we take that bx minus c, set that equal to 0. So that means your bx was equal to c, and x is equal to c divided by b. That's going to give you what that phase shift is. So what point are we starting at for the beginning of that cosine function? So the graph of y is equal to a cosine of bx minus c is obtained by horizontally shifting the graph of y equals a cosine bx. So the starting point of the cycle is shifted from x equals 0 to x is equal to c divided by b. If c divided by b is greater than 0, then it's shifted to the right, and if it's less than 0, it shifts to the left, and that number c divided by b is called that phase shift. So we know how to find the amplitude, we know how to find the period, we know how to find a phase shift. Let's do it. So it says to determine the amplitude, period, and phase shift of y is equal to 3/2 of cosine of 2x plus pi, then graph one period of the function. So let's go and identify our amplitude. Well, if we had that 3/2 of cosine of 2x plus pi, the number in front of our cosine is going to end up being our amplitude. The absolute value of a 3/2 is just going to give us a 3/2. So it's going to go 1.5 above the x-axis and 1.5 below the x-axis. The period is found by taking the 2 pi, dividing it by the b value. Our b value is going to be at 2. So if I take a 2 pi and I divide it by 2, that's going to give a period of pi. Our phase shift is the c divided by b value. Now the c value, we have to remember that this is technically after a minus sign. So if it's a plus pi, that means that our c value is going to end up being a negative pi. So we're going to have a negative pi divided by our b value of 2. When in doubt, take this 2x plus pi, set it equal to 0. So 2x equals negative pi, which means x is equal to negative pi over 2. That helps you also to identify that phase shift. So now that we have some of that information, let's go ahead and find those x values. So the period we found was pi. So if we divide that by 4, we're going to change by increments of pi over 4. Now it says to find the x values for those key points. So x sub 1, we had a phase shift. Because we have a phase shift, it changed to a negative pi over 2. Our starting point is going to be this negative pi over 2. And then we're going to add those increments of pi over 4. So if we have a negative pi over 2 and we're going to add in a pi over 4, that means we'd have a negative 2 pi over 4 added with pi over 4. We're going to end up with an x2 value of a negative pi over 4. Now, if I take a negative pi over 4 and I add in my change, my pi over 4, that's going to take us to 0. And if I start at 0 and I add a pi over 4, that's going to give us pi over 4. And if I take pi over 4 and I add pi over 4, that's 2 pi over 4, which is a pi over 2. So now we have our 1, 2, 3, 4, 5 x values. Take it to the table. Once we take that to the table, we're going to fill things in, right? So we're going to take our 2 times that negative pi over 2 plus pi. These cancel, so we have a negative pi that adds with pi, which gives us 0. And if we have a cosine of 0 ends up giving us 1. That means we have a 3/2 times 1, which gives us a 3/2. So when we're at negative pi over 2, we're at 3/2. If I simplify my next one, that's going to give me a negative pi over 2 added with pi, which gives us a positive pi over 2. So cosine of pi over 2 is going to give us 0. So if we have 3/2 times 0, we end up with 0. So at negative pi over 4, we're at 0. Continue on in our table. If we were to take 2 times 0 is 0. We add pi. That means we're finding our cosine of pi. Cosine of pi ends up giving us a negative 1. So we have 3/2 multiplied by a negative 1. So we're at negative 3/2. So 0 comma negative 3/2. 2 simplifies 4 down to 2. So pi over 2 plus pi gives us a 3 pi over 2. Cosine of 3 pi over 2 gives us 0. So 3/2 times 0 gives us a 0. So pi over 4, comma, 0. And then the last piece, let's see, we're going to have our cosine of 2 pi. Cosine of 2 pi gives us 1. So 3/2 times 1 gives us a 3/2. So pi over 2 and 3/2. Once we have those 5 key points, we'll take it to the graph, right? So when we were at negative pi over 2, we are up here at a 3/2. When we are at negative pi over 4, we are at 0. When we were at 0, we are at negative 3.5. When we are at pi over 4, we were at 0. And at pi over 2, we're back to that 3/2, or that 1.5. Now, they had wanted us to graph between a negative 2 to a positive 2. So you would have had to extend, I believe it was a negative 2 to a positive 2 on this one. Sorry, going back. Nope, they just wanted one period. The other one was from negative 2 to positive 2. So all they wanted was one period, so we have one period graphed.